This is the notes for section 8.5. So in this section, we're going to be using our trigonometry principles to solve more complex problems. Sometimes where you have to do multiple steps and find multiple different pieces of information. So just a review about angle of elevation and angle of depression. So a reminder that angle of elevation is always from the ground up at an angle, okay, like this. That's the angle of elevation. And then the angle of depression, you make an imaginary line in the sky, and then it's going down this way, okay? And that's the angle of depression. And then another thing to remember is that if you have two parallel lines like this, and you draw a straight line between them, whatever this angle is identical to this angle. Okay, so this angle and this angle are identical. Okay, that's just a rule about angles and lines. Okay, so let's take a look at one of these more complex questions. So this one says, the top of an arbutus tree, broken in the wind, hits the ground 16 meters from the base of the tree. So you had a really tall tree, it got snapped in half, and now it's broken. Okay, so let's draw that first. So we're going to start off with our ground. So there's our ground. Then we have half of a tree up like this. Oops. So here's my tree. And it used to be even taller. It used to go up all the way here, but it's now broken, and part of it has fallen to the ground like this. That's the other part of the tree. Okay. So it used to be tall, but it got snapped, and now part of it's on the ground. And it hit the ground 16 meters from the base of the tree. So this is the top of the tree. Here's the base. So in between here is 16 meters. And it says if the top of the tree, so here's the top, now makes an angle of 22 degrees with the ground. Hey. So it's saying that this here is 22 degrees. What was the original height of the tree? So it wants to know the original height. So X and Y. So the original height means, like, let's say it stood up to here. Okay, it wants this whole distance. So you need to figure out the length of this piece, and you need to figure out the length of this piece, and then you need to add them together. Okay, so we need to find both X and Y. So this is similar to our solving a triangle for this question. Okay, so the first thing we need to do, we're going to find X. So step one, we're going to find X. So to be able to find X, we need to label. So we have our right angle. So this is going to be our hypotenuse. We have our indicated angle. So this is going to be our opposite. And then we have our other side, and that's going to be adjacent. So we know we're using adjacent. To find X, we're also going to use side opposite. So we have opposite and adjacent. So when we have opposite and adjacent, we're going to use our tan. So we're going to use TOA. So we get tan of our angle is equal to opposite over adjacent. And we know our angle is 22. So we get angle is equal to tan, oops, I don't want to find angle. Undo. Tan 22 is equal to, my opposite is X, and my adjacent is 16. Since my number is on the bottom, I'm going to move it over here. So I get I get 16 tan 22 is equal to x. So when I put that into my calculator, my x is 6.46. Okay, so that's step 1. Step 2, I'm going to find y. Now I'm going to find y. So for y, I'm still using adjacent, and this time I'm also using the hypotenuse up here. So I know that, adjacent and hypotenuse, that's going to be my cos. So cos of 22 is going to be equal to adjacent, which is 16, over my hypotenuse, which is y. So this time the letter's on the bottom, so I'm going to switch those two. So I get y is equal to 16 over cos 22. And then I'm going to put that into the calculator, and I get 17.26. And then step 3, I want the total height, which is equal to x plus y. I need to add those two together. So I'm going to add 6.46 plus 17.26. And then it says here, round to the nearest tenth. So usually when you're doing these types of questions, you want to leave extra decimals until the very final step, and then you round your final answer to whatever they say in the question, okay? And that makes it more accurate. So I'm going to add these and round them, 23.7 meters. So the original height was 23.7 meters. If you were going to write that as a sentence, I'm running out of room, so I'm just going to do it like that. Okay, so that was how you would do this question. Let's try another one. An isosceles triangle. So remember, isosceles means one side different, two sides the same, has a base of 28 inches. If the legs, which is another word for the two equal sides, meet at an angle of 34 degrees, how long are they? So let's draw a triangle. And they're saying that it has 28 inches base and 34 degrees top. And these two are the same. And they want to know what the length of either of those is. So whenever you have an isosceles triangle, you do not have a right angle. So to solve any isosceles triangle questions, you always have to, I'm going to use a different color. You always have to cut your triangle in half to be able to solve it. And then draw a new cut in half triangle. So this is going to become, that we're actually going to solve. We have the dotted side, then this, like this. Okay, so we know that's 90. If you take your 28 and you divide by 2, you get 14. If you take 34 and you divide by 2, you get 17. So this up here is going to be 17 degrees. And this down here is going to be, hey, my pencil died. There we go. Okay. It's going to be, 14. Okay. And we are looking for x over here. So first thing we're going to do is we're going to label. Here's our right angle. So this is our hypotenuse. Then this is our indicated angle. So across here is our opposite. And then this is the adjacent. Then we're going to circle, we have this information, and we have this information. So now we can solve for our x. So we have hypotenuse and opposite. So we're going to be using our sine. So sine of an angle is equal to opposite over hypotenuse. So we'll fill in the information that we know. We know our angle is 17, our opposite is 14, and our hypotenuse is x. Since the letter's on the bottom, we're going to switch those two. So you get x is equal to 14 over sine of 17. And then I'm going to put that into my calculator, and I'm going to get 47.9 inches. So the legs are 47.9 inches long. That's the final answer for this question. Okay, let's try another one. The CN Tower is 1,815.4 feet high. All right, so let's draw some ground. Let's draw a tower. And it says it is 1815.4 feet high. All right. Miss J measures the angle of elevation to the top of the tower as 36 degrees. Mr. Leflizdert, whatever, directly opposite the tower, measures the angle of elevation to the top of the tower as 23.5. Okay, so one of them is over here, and one is directly opposite, so one's over here. So let's say this is J, and let's just say this is L. So we can draw a line of each one to the top of the tower. Okay, and it says Miss J's angle is 36 degrees. So this is 36 degrees. And L's angle is 23.5 degrees. And they want to know how far apart are Miss J and Mr. L. So X and Y. So this is another one where we have to find X, we have to find Y, and we have to then add them together. So we're going to treat this like it's two separate triangles. We're going to use this information over here to find X, and then we're going to use this information over here to find Y. Okay, so let's start off by finding X. So step one, we're going to find X. So we need to label. So for both of those, that's our right angle. Oops. So across from my right angle is going to be my hypotenuse. This is going to be opposite. And this is going to be adjacent. So I have opposite and I have adjacent. So opposite and adjacent together is going to give me tan. So tan of my angle, which is here 36, is equal to opposite, which is 1815.4 over adjacent, which is X. My letters on the bottom, so I'm going to switch. So I get X is equal to 1815.4 over tan of 36. So I get X is equal to 2498.68. All right, so that's finding X. Next step, I'm going to find Y. So now I'm looking at this side of the triangle. So here is my right angle. So this is my hypotenuse. This is still opposite, so I can leave that because there's the angle there and it's still opposite there. And then this is adjacent. So I have adjacent and opposite, so I'm doing another tan. Still TOA. this time I have different numbers that I'm going to use. I have tan of 23.5 is equal to opposite, which is 1815.4 over adjacent, which is y. So again, I'm going to switch those two. So I get y is equal to 1815.4 over tan of 23.5. Y is equal to 4175.13. And step 3 is the distance apart. So this is going to be x plus y. So we want the whole distance between J and L, x plus y. So we're going to add those two numbers, 2498.68 plus 4175.13 is equal to 6673.8 feet apart. Okay, and that's how far apart they are. And I rounded to the nearest tenth, so 1 decimal place, because it says 2 here. But I left more decimal places for accuracy until the last step. Okay, so in this question, you're just considering them as 2 separate triangles. Okay. Is this the last one? Yeah, okay. A lighthouse keeper, Mr. Trigg, who is at the top of a cliff 300 meters above sea level, spots 2 ships directly offshore. Okay, so first we're going to have, this is our ocean. Okay, and here's the cliff and the lighthouse on top of the cliff. Okay, and there's 2 ships, a ship here and a ship here. Okay, so let's say ship. And Mr. Trigg spots those ships. So let me fix Mr. Trigg. There we go. And this is Mr. Trigg. This is Cliff. Okay. Okay, so he's atop a 300-meter cliff. And he spots these 2 ships. The angle of depression of the ships are 4.5 and 6. So angle of depression means that we need to draw a dotted line. Ugh, that's a terrible dotted line. Let's try again. Okay, there's my dotted line. I'm gonna use a different color so it's easier to see. And there's one, whatever's a smaller distance, that's gonna be 4.5. So let's start with that one. I'm gonna figure out what line that is. I'm gonna trace it down. So it's gonna be this line. And I'm gonna say that this is 4.5 down here. Okay, because remember that rule from the beginning. Then my larger line is going to be 6. So I'm going to trace that line down. It means this angle here is 6. Okay. And it wants to know how far apart are the ships. So we have a few distances that we have to take into account. So it wants to know this distance. Okay, that's what the question is asking. To be able to find that, it means we need to find x, which is the distance from here to here. That's going to be x. And then we also need to find y, which is the big triangle the whole thing there is y. Okay? To do that, we're going to consider this as two separate triangles. Okay? We're going to have one triangle that has 300, 6 degrees, and x on the bottom. We're going to have a second triangle that has 300, y, and 4.5 degrees. Okay, so these are our two triangles. And what we're going to do is we're going to figure out both lengths, and then we'll just do y, take y, subtract x from it. So basically, then it'll just give us this little piece. If we take all of y and subtract x, we're just left with this, the distance, and that'll be our final answer. Okay, but first we have to consider each of these two triangles separately. Okay? Okay, so let's label our triangles in pink. So these are our right angles for both of our triangles. So here's hypotenuse. Then we're going to trace from our angle. It's going to be opposite. And this is going to be adjacent. So we're using opposite and adjacent for both of them. So our step 1 down here is going to be find x, and opposite and adjacent is going to be our TOA again. So tan of 6 is equal to 300 over x. So we can switch these. So we get x is equal to 300 tan of 6. And when I do that, I get 2854.31 meters. Step 2 is going to be find y, again with TOA. Here we have tan of 4.5 is equal to 300 over y. Switch those and get y is equal to 300 over tan of 4.5. Y is equal to 3811.86 meters. And then step 3 is distance. So I'm going to do y minus x to find my distance. So that's 3811.86 minus 2854.31. And when I do that subtraction, I get 957.6 meters apart as the final answer. So this distance here is 957.6 meters. Okay. Now in terms of, the homework for this section, I accidentally closed it. Chapter here. No. Here. Chapter 8. It is page 330, number 1 to 3, number 5 to 6. Okay, and that is it for this section.